today also we are going to see some more problems related to combination and permutation. The first problem is you walk into your candy store and have enough money for 6 pieces of candy. The store has chocolate gummies and horrible Chinese candy. How many different selections can you make? So first we have to determine whether the order matters or not. Of the 3 types of candies, we are going to pick some 6 candies. So where the order of picking the type of candy doesn't matter, and whether the elements are repetitive. See, we are having 3 types of candies and we have to pick 6 pieces from out of it, right? So naturally we can understand that there is a need for repetitiveness so that we can accomplish the 6 pieces of candies, right? So the repetition is there. Okay, so we from after the 4 formulas we had for the combination and repetitive nature, the formula we are going to use for finding out the outcomes is n plus r minus 1 factorial by r factorial into n minus 1 whole factorial. So just substitute the values here. 3 plus 6 minus 1 by 3 minus 1 factorial, where the answer is going to be 28. Okay, next, suppose a true or false test has 20 questions. In how many ways may a student mark the test if each question is answered? So every question has 2 choices. If you mark true for the first question, then for the next question also again you are having 2 options, true and false, and we are going to pick the answer, right? So the elements are repeated, the choices are repeated for every question. Okay, and the order matters because we have to answer the questions, and the number of choices available is 2, and the questions is 20 in number. So we know the formula for finding the permutation with repetitive elements is n power r, which is equal to 20 power 20, and the answer is this many outcomes. Okay, we'll move on to the next problem. A company president is deciding how to fill 3 vice presidencies in the company: VP marketing, VP finance, and VP production. 12 executives are eligible and qualified for promotion, and each would fill in any of the 3 positions. In how many ways can the position be filled? So here they of the 12 people, 12 executives, they are going to select VP marketing, VP finance, and VP production. So they are going to have some specification in their selection. So the order matters, and the element is not going to be repeated, because if a person is selected for VP marketing, then VP finance is going to be something entirely different person. Okay, so it is not going to be repeated. It's 12 choices and we are going to pick 3. So finding the permutation without the repetitiveness nature is going to be like 12 factorial, like 12, 11, 10. Right, this is the normal permutation way we used to, and these are the number of outcomes. From an unlimited selection of 5 types of soda, one of which is Dr. Pepper, you are putting 25 cans on a table. Determine the number of ways you can select 25 cans of soda. So we are having 5 types of soda, and we are going to pick up 25 cans out of the 5 types. Okay, so the number of elements that we are choosing is more, and ultimately it shows that it is going to be a repetitive element. And which type of soda you're going to pick first or second doesn't matter, so the order doesn't matter. So the combination formula for the repetitive nature and the the order is matter. We have to, the formula is n plus or minus 1 by n minus 1, the factorial. By substituting the values, we are getting the answer as 2, 3, 7, 5, 1. Okay, so finding whether the order matters and the repetitive nature, we will be able to find the correct combination. That is what I'm trying to make you understand with the all these examples. Okay, one last example. I forgot to buy vegetables from our dinner party tonight. Will you go back to the store and get 3 bags of different frozen vegetables? In the store, if the store has 10 bags each of 20 different frozen vegetables, in how many ways with respect to kinds of vegetables can the errand be performed? In this problem, words are very important. See, it's asking us to select 10 bags each of 10 different vegetables. How many ways with respect to the kinds of vegetables? Right, this word is very important so that we can choose n as 20. Okay, otherwise they may make a mistake of, if the store has 10 bags each of 20, so 10 times 20, 200 bags also we can suggest, but they are clearly saying that with respect to kinds of vegetables, so there is 20 different kinds of vegetables, so just put 20 as n. And what we have to select, we have back to the store and get 3 bags of different frozen vegetables. The word different is very important. Okay, different frozen vegetables means these 3 bags of vegetables should not have the repetition, so the elements are not getting repeated. Okay, order doesn't matter because any type of bag you can choose first or second or third, but the thing is all the bags should be of different types of vegetables. And so we know the formula, combination equals permutation by or factorial. Permutation is 3 choices, right? So 20, 19, 18 by 3 factorial, and the answer is going to be 1140. I hope with all these examples you will be very easily able to determine whether the order matters or not and the elements are repetitive or not. Okay, so be very careful in reading the sentence and finding out these 2 reasons, and with the formulas you will be able to reach out the outcomes. Thank you very much for watching the video. If you like it, comment and share with your friends. Subscribe my channel if you haven't done so far. Thank you.